Imagine, how cool exactly would it be if you could eat a bird and get wings as a result? And how about you go on to eat a fish and all of a sudden you can go scuba diving without a bulky mask for oxygen? I mean, this does seem impossible, but in fact, nature does this all the time. How else do you think this fiery ball of disappointment turned into the green planet that you're watching this video on? And how else do you think these peculiar looking things transformed into the cells that form some of the most complex organisms thriving today? Well, one of the most supported explanations of this is the theory of endosymbiosis. So here's a little story. Once upon a time, over 2 billion years ago, there was a pretty prokaryote named Claire. Now, what was special about her was that she had superpowers that no one else had at that time. She could absorb photons and easily make her food out of it. Believe it or not, she also had a pretty cool prokaryote brother named Michael. Now, what he could do is that he could take a chunk of glucose and turn it into adenosine triphosphate. One day, a huge prokaryote swallowed these siblings. So now what? The huge prokaryote gave Claire and Michael a safe place to live inside of it, while the siblings in turn helped their host manage its food and get energy out of it. And the cool thing is how these immortal superheroes continue to survive today. Claire became chloroplast and Michael became mitochondria. So what's the proof? So far, scientists have discovered 3 ways to help support the theory of endosymbiosis: DNA, cell division, and membranes. So let's start off with the easy, DNA. Unlike every other organelle in an animal or plant cell, mitochondria and chloroplasts have their own DNA. They also have ribosomes that have similar structure as that of those in ancient bacteria. Just like the DNA of those bacteria, the DNA of these organelles is circular in structure and contains many similar genes. Number 2. Cell division. In ancient times, when sexual reproduction wasn't possible, bacteria used to perform a type of asexual reproduction called binary fission. Surprisingly, mitochondria and chloroplasts also use the same technique to make more of themselves. And finally, membranes. Both chloroplasts and mitochondria have 2 cell membranes that have totally different characteristics. So how does this relate? So when the host engulfed the smaller bacteria, they retained their original membranes but also got wrapped in another outer membrane of their host. And if we actually look at the modern-day chloroplasts and mitochondria, the lipids found in their outer membrane are very identical to those found in the membranes of ancient prokaryotic bacteria.